So in physical work, there are two types of physical quantities. Okay, what are those? Physical quantities. There are two types. One is scalar and the other types of quantities are called vectors. Why the concept of vector we will learn? This is very important. Concept of vector why you have to learn. Scalar quantities you know. Scalar quantities they have magnitude only. For example, if we want to measure the length of this board where I am writing, that measurement is a scalar quantity. So, measuring length, mass, even when you are adding two scalar quantities, addition of two scalar quantities will be a scalar quantity only. So, just mass of an object, mass of an object, or length. They are scalar quantities. If you want to add two masses, one is say 5 kg, the other one is say 2 kg, then 5 kg plus 2 kg will give us 7 kg. But suppose there is an object where this is the object, it has a specific mass that I am not writing here. On this object, in two different directions, two forces are acting. One force acting this way, say this force F1 equal to 5 Newton, this is F2 equal to 10 Newton. The acceleration of the object is not dependent on only 5 Newton or on 10 Newton. Acceleration is what? Acceleration of the object equal to force by mass. This force is what? You will say acceleration towards right, acceleration upward. Not like that. The object will move in one direction only, neither along F1 nor along F2. So in what resultant direction, what final direction it will move, it has tendency to move towards right. It has tendency to move upward towards right due to the force 5 Newton, upward due to the force 10 Newton. But this object does not move towards right or upward. It moves some other direction like this. Object will go some other direction. How to get that direction? Not just by writing F equal to 5 Newton plus 10 Newton and divide by mass of the object, say 3 kg. No, that is wrong. So here what you have to do, you have to find the net force. After getting the net force, you can get the acceleration of the object. So acceleration by now we'll be writing, which you have never written before, acceleration equal to resultant force Fr divided by m. Okay, but then mass, total mass, m total, what we have written here, 7 kg. No symbol required for that. But when you are going to represent a vector quantity, then you have to use one arrow like this. This arrow may be shorter, there is no problem. But you have to put an arrow to understand a vector quantity. This vector quantity, it has both magnitude and direction. It has both magnitude and direction. So this vector, acceleration is a vector, it has magnitude and direction both. Force is a vector. So this equation, instead of writing this manner, by now we'll be writing this by m. Acceleration vector equal to force vector divided by m, the mass of the object. Okay. So what are other vector quantities? For example, just I have given force, acceleration, velocity, these are vector quantities. Even torque also, that you will learn in class 11 only, these are vector quantities. And when you are representing a vector quantity, that you will always do with the help of this arrow. These vectors, when we are treating mathematically, then we have to know a few terms, a few definitions. A few types of vectors I'll tell you now in the introductory class, that if when you are representing two vectors, they can start from same point. They cannot start also from the same point. Okay? But there is a very important property of vector, that a vector can be slid parallel to itself. On an object, I'm telling you, when two forces are acting, the way I told you, these are two forces acting. If you produce these two forces, they will be meeting at a point. These two forces will meet at a point, definitely. But how to take them for meeting? That if one vector is slid parallel to itself, if two vector is slid parallel to itself. If you do this manner, then they are meeting at a point. But if they are even not meeting, we can try to meet them, because a vector, this is a very important property of vector, a vector can be slid parallel to itself. You can move a vector parallel to itself. Now, when they meet, this definition part, let me tell you, when they meet at a point, they are emerging out of this point, say, then these two vectors are said to be co-initial vectors. There may be third vector also. I can draw another vector here. These are called co-initial vectors. So what are co-initial vectors? If they have the same origin. For any vector, I'm just writing a vector A here, see. This is a vector A. And this we are representing by this line segment. Line has infinite length, but vector cannot have infinite length. Why? Because it has fixed magnitude. So we have to represent it by a line segment. Okay? So better we follow this definition by now. A vector is a directed line segment. And when two or more vectors starting from the same point, this O is called here the vector OA. O is known as origin or tail of the vector. and A is called the tip of the vector. Tip. So tail and tip, starting point and finishing point. The length of this line segment will be the magnitude. Okay, it has fixed magnitude and it has fixed direction. That's why it is vector. Co-initial vectors are what then? If two or more vectors have, if two or more vectors have the same starting point, they are called co-initial vectors. So these two vectors, these three vectors A, B, C are co-initial vectors. In this diagram, A, B and C are co-initial vectors. Vectors can be parallel also. What are parallel vectors? Is it possible parallelism? Let me explain. If two vectors have the same direction, they are called parallel. So this vector A and this vector B, they are directed in the same manner. They don't have the same origin. So these two vectors are parallel. We'll simply write A parallel to B. The vector A is parallel to the vector B. We'll simply write this. But tell me one thing, when you have studied this very important property, this property is very important. A vector can be slid parallel to itself. So we can slid the vector B towards the vector A or A towards B. We can make them collinear. So for vectors, parallelism implied collinearity. Never forget this. Parallelism and collinearity, there is no difference. In case of vector, parallelism means collinearity of vectors. So there are many other types of vectors, but those vectors I will be telling you chapter wise. Okay? Right now, let us proceed to understand the magnitude of vector and unit vector. When you are using this symbol, this is just a vector. When you are using this symbol, this is also a vector, but this will have a special name. This is called unit vector. What is that? Let me explain. I have given you one vector A. Okay? Suppose length of this vector, that length of vector A, we write by this symbol, mod A, or modulus of the vector A length, or modulus, or there is another name, that is magnitude of vector. Length or modulus or magnitude, whatever you say, of the vector is represented by this symbol, mod A. Okay? So, if this vector has length say 1, 2, 3, 4, 5, 6, 7, 8, 9 units, we'll write mod A equal to 9. Okay? If the vector A has length 9 units, we'll write mod A equal to 9. Okay. So modulus or magnitude of the vector is understood. That is the length of the vector. Now, if there is a vector A like this, can I draw a vector of magnitude 3 units in this direction? This vector is given. Which one? That vector A. Vector A has magnitude. How much? Vector A has magnitude 9 unit that I told you. Now, we want to draw a vector of magnitude 3 unit in this direction. How to do? You can say that the vector is this. I have taken B1 vector, its magnitude is 3 unit. Someone want to write a vector, I'm writing mod V1 equal to 3. I am writing another vector 1, 2, 3, 4, 5. Say. Okay, in this direction 1, 2, 3, 4, 5. So this vector will be 2. Mod B2 equal to 5. We'll think about writing all these vectors in terms of unit vector along the direction of E. Let me write a vector of magnitude 1 unit only along the direction of E. This is the vector. Its magnitude is 1. This is the vector along the direction of vector A. Its magnitude is 1. Mod A. But this you never write by using this symbol. This you will write by using this symbol. Why? Because it has magnitude 1. So this A cap is what? See, all these three vectors, they have the same direction as the vector A, isn't it? Only magnitude of the vector A is 1 unit. This A will be referred as unit vector along the direction of the vector A. This is unit vector along the direction of the vector A. So how I have written that? Just for this example, one can say that this A vector going to be what? A vector, a cap vector is going to be 1 by 9th that of vector A, isn't it? 1 by 9th, because it was 9 unit and this is 1 unit. Or you can write this thing like A divided by mod A. Okay? So this is actually our definition of unit vector. Unit vector along the direction of vector A will be defined as unit vector A cap along the direction of vector A is defined as A cap equal to E divided by mod A. Okay, this is our definition. Now, what is the advantage of this thing? One can say that these can be used to assign direction. A cap can be used. A cap can be used to assign direction. So this A cap you know. Can you write a vector 3 A cap? This part is important. Unit vector you have to understand properly. How can you write 3 into A cap vector? 3 into a cap means what? 3 into a by mod a, isn't it? But in this diagram, if you see the vector v1, b1, then b1 is what? Actually 3 into a cap. This, what I have done there, this vector, I have magnified 3 times in this direction. Then I get b1 vector. How can I represent b2 vector then? B2 vector going to be B2 divided by mod B2. Oh, sorry. B2 vector you can write, this is a 5 unit, no? So you write 5 into a cap. Clear? So if this is unit vector, this unit vector can be used to write any vector in the direction of a given vector. I am writing the application separately. Use of a cap. What is that? That I have already explained. A cap can be used to write a vector of, can be write to represent a vector of, to represent a vector of certain magnitude along the direction of the vector A. Okay? A cap can be used to write to or represent a vector of certain magnitude along the direction of the vector A. Clear? Understood? So how can I write the vector B of magnitude m? Therefore, a vector of magnitude magnitude m along a vector of magnitude m along the vector A is given by what? B equal to m into a cap. Understood? B equal to that I have done. B1 equal to 3 a cap. You have seen that. B2 equal to 5 a cap. Why? Because 5 is the magnitude. 3 a cap, why? Because 3 is the magnitude. So a vector, you can write a vector B of magnitude m along the vector A can be always written this form, B equal to m into a cap. Clear? Now, negative of a vector. How do you represent negative of a vector? Vector has a direction. Suppose I have taken this vector R equal to AB. This R vector is AB. This is the initial point and this is the finishing point. If I draw the same vector but direction this time just opposite, directed from B to A, then BA vector is going to be minus of AB. It is given by minus R. Clear? So we can write a vector PQ equal to minus of QP. Clear? Understood? Now, if I tell you, if I give you one task to do, suppose I have given a vector let A be a given vector of magnitude 5 units. Draw number 1 vector A, number 2 vector A by 2, number 3 vector minus A by 2, number 4 vector say A by 5. Just do this thing. So this one, okay, A vector, its magnitude 5, we have taken 5 unit vector. This is going to be A by 2. Why? Because 5 by 2 is 2.5 unit. So this will be vector of magnitude 2.5. We have taken accordingly in the same direction. This you can also write in this form, that B1 equal to A by 2. B1 equal to A by 2. If you want to write in terms of unit vector, you write 2.5 A cap. So this will be what? B2 equal to minus B1. Just opposite direction, magnitude has the same value. 1, 2, and this is 2.5. And the last one is very easy. A cap is A divided by mod A. This is A by 5. Now we are going to learn the addition of two vector quantities. It will not be like scalar quantities. Two masses, 5 kilogram rice and 10 kilogram rice. When you add them, you'll be getting 15 kilogram of rice. It's not like that. Instead, as I told you earlier, two different forces are acting at two different points from the same point or at different point on the object. We can make them co-initial, and then how to find the resultant, that we are going to discuss now. So, in addition of two or more vector quantities, we have the triangle law. Addition of vectors. We'll learn these three laws of addition of two or more vectors. First one, triangle law. I am writing parallelogram law, second one, but this is basically same as that of triangle law. Same thing, there is no difference. And the third one is polygon rule. What is triangle law of addition of two vectors? Number one, triangle law. What is that? There are two vectors initially. One vector acting this way, second vector acting this way. The angle between two vectors. One thing I am telling you, these two vectors are not co-initial. One vector is going this way, and it is the finishing point of one, and this is the same point is the starting point for the other. This is vector A. Now, what is the angle between two vectors? I told you vectors can be slid parallel to itself. So, if I have taken two vectors this manner, A and B, then really this is the angle. Because I have taken two vectors, they are co-initial. Really this is the angle between two vectors. But here, angle between two vectors will not be this one. You have to make them co-initial. So produce this in forward direction. This is going to be the angle between two vectors. Clear? As if the vector A, we we move it forward to make A and B collinear, and this is going to be the angle. So here angle is going to be this thing, angle between two vectors. Am I clear? So I'd like to take one more example here, because otherwise it can give you trouble. Two vectors are terminating at the same point. Then this is the angle between two vectors. So when two vectors are originating from the same point or terminating at the same point, then the angle between two vectors is easy to understand. But problem arises when one of them is meeting, the other one is emerging out. Then to find the angle between them, we have to follow this method we are producing. We imagine that. If you don't take it, actually no problem, but imagine that this is taken forward, because by keeping the magnitude same, it can be slid along its own direction in parallel direction. So angle is this thing. Please remember it. Okay. So what is triangle now? Let us try to understand first. If two vectors are taken along, two vectors A and B are taken along two sides of a triangle in magnitude. This is very important. In magnitude and direction, then the third side of the triangle taken in opposite order represent the sum. Sum means you can say resultant also. Resultant of the given two vectors. What is the physics in this mathematical statement? Two vectors A and B are taken along two sides. First, let me explain. How are you taking along two sides of a triangle? Triangle is not shown in the diagram. Suppose the triangle is L, M, and N. I stated that two vectors taken along two sides in magnitude and direction. So length of LM is actually magnitude of vector A. You will say that LM also has direction. Why you are not writing that? I am telling you one convention. You write length of A equal to length of LM. No problem. But there is another presentation of magnitude of vector. We can simply write LM. So if we write A only, what does it represent? Instead of writing a vector, if you write simply A, what does it mean? This is length of the vector. Okay? We need not put this sign always. You put this one simply. This will represent the length of the vector. Clear? So here, A vector directed this way, B vector directed this way. It means magnitude of B vector is what? Length of Mn of the second side of the triangle LMN. Now let me complete the triangle here. If we complete the triangle, then this one taken in opposite sense will represent the resultant. R will be, you can write NL vector or R vector. So R is going to be sum of these two vectors. Understood? Probably nothing is understood. What is the meaning of writing this thing? How does it help? Can we add them algebraically? If A has length 7, B has length 5, can I say that R has length 7 plus 5? No, you can't say it is 7 plus 5. That we have to find by using trigonometry. Clear? So we are going to do that. Before that, I tell you one thing. The resultant has the magnitude. This molar is also LM. This I have explained. If R is the resultant, this is actually NL. So when you are writing R equal to A plus B, just to represent vectorially R represents the resultant of these two things. But magnitude you don't know. And in what direction R vector acting, that also we don't know. One mistake I have done there, this vector will have direction. What I have said it, taken in opposite order. Opposite order means this arrow will go this way. Clear? So where is the physics lying over there? Say on an object, on any object, one force acting this way, another force acting this way. I told you, object never move along the direction of force F1, or along the direction of force F2. It goes some resultant direction. What is the resultant direction? It is given by R. Okay? You can add you can add any two vector quantities, not only forces. Two velocities can be added. You see how the body can have two velocities, can have two different directions. This is resultant direction of velocity. Might have two accelerations because two forces are there, two accelerations. Their resultant will be in this direction. Clear? But we have to do very important thing about this, that magnitude and direction, that we did not find. How to get the magnitude and direction of this vector, this I am going to explain. I mean length of the vector R. Okay? This is L, this is N. Okay? So we are going to calculate to find the magnitude and direction of R. How to find it? Let me explain. So this is the triangle. We have to use some trigonometric method to get it. That we are going to do. So what we'll do here, we'll produce this in forward direction. We will draw a perpendicular from the point N to the produced part of LM. This perpendicular be in R. In R with the perpendicular. You have understood? There is a triangle now in RM where angle NMR equal to theta. See how to find the magnitude. So in this triangle, in RL, this is right angle triangle because you have drawn a perpendicular. NL square equal to LR square plus RN square. NL is what? Length of vector R. So we can simply write R square equal to, what is LR? LR is LM plus MR. Then we can write plus Rn square. See, our aim is clear. We just want to find the magnitude. Use Pythagoras theorem. Twice Lm into Mr plus Mr square plus Rn square. So this is going to be Lm square plus 2Lm into Mr. We don't want to keep it in terms of Mr. We will change it. So in triangle MRN, Mr by Mn is what? Cos theta. So Mr going to be what? Mn cos theta. What is Mn over there? Mn is length of the side of the triangle element, and this is actually mod B or simply B cos theta. Mr is B cos theta. You substitute there, will do. Mr is Mn cos theta. Also in triangle NMR, what do you observe in NMR? We can use Pythagoras theorem there also. In triangle MRN, Mn square is Mr square plus Rn square. Clear? So R square, now we have got in terms of all the sides. Ln is what? A square plus 2 into A into Mn. Mn is how much? B plus B square. Am I clear? So I got the value of R in terms of A and B now. So R equal to what? Under root A square plus B square plus 2AB cos theta. Clear? Now, after getting the magnitude R equal to root over A square plus B square plus 2AB cos theta, we are obviously interested to know the direction. This direction is what? Okay, this direction be alpha or phi. We are assuming the direction be phi. We are going to find magnitude. Magnitude is found. You put A, B and theta over there, you get the magnitude. We want to find direction over there. So what I am going to do to find the direction of R. How to? See, in triangle, same triangle, in triangle LRN, tan phi equal to NR by LR. What is NR? See, consider this triangle again. NR by Mn equal to sin theta. Isn't it? NR by Mn equal to sin theta. So you write one more step. NR and this LR will be Lm plus Mr. Substitute there the value of NR. Mn sin theta, that divided by Lm. Lm is Lm, we know the length. Mr by Mn is what? This we have done before. Cos theta. So put it there. Mn cos theta. So Mn, now put the value. Mn is B. B sin theta by Okay. So tan phi equal to b sin theta by a plus b cos theta. From here, phi can be determined. I can use a mathematical symbol here. Phi equal to tan inverse. Inverse function you don't know, you need not know. So fast you cannot know everything being a class 11 student. But remembering this formula will help you to get the values from your calculators. Shift tan, then calculator it will be changed to tan inverse, then put the data over there, you will get the angle. Clear? In exam, CBSE students will not get this facility because calculator not allowed in school or board exam. But right now you can do it. So by using these two formulas, you can get the magnitude and direction. I am just writing a simple example here. This vector is of magnitude, say 3 units, and this one 4 units. Angle between them, say, we take the angle between them is pi by 3. Pi by 3 means 60 degree. Find the resultant of these two. How to get? Just draw the diagram. Find the resultant means you have to find both magnitude and direction. This angle is r phi. So first you write mod r. Mod r going to be what? 3 square, 4 square, cos pi by 3. 25 plus 12. Because pi by 3 is half. So root 37 unit. And angle phi how to find? Tan phi equal to 4 sine pi by 3 C plus 4 cos pi by 3. Two root 3 by 5. So phi equal to tan inverse 2 into 1.732 by 5. Right now I am doing it with the help of my calculator. Both root 37 we have to find and shift 10. That will tell you how to find the angle. Okay? Just a minute. This is coming 6.08 units. This one you try in your calculator. Okay? That I am not going to show. Clear? Done? You have understood one simple application. Now, to apply this in solving problem, you have to know two more important facts like what is the maximum value and minimum value of this resultant. How you get that? Maximum and minimum value of resultant. Resultant you got by this formula. What is the maximum value? Maximum and minimum values of R. This will help you to solve problem. R is maximum when cos theta is maximum, isn't it? That is cos theta 1. So our max going to be what? A square plus b square plus 2ab. This is a plus b. R is minimum when cos theta is minimum. That is, so R mean is what? So this is a very interesting case. You should remember that maximum and minimum value is given by respectively their sum and their difference. Can you give a physical example? Yes. Under what condition two forces give the maximum resultant? When they act in the same direction. This is the object. On it, two forces are acting. F1 equal to 10 Newton, F2 equal to 6 Newton. For maximum value of the sum, they should act in the same direction. F max okay. F minimum when F mean is the difference. This will be this time 10 minus 6. F1 minus F2. Maybe F2 minus F1. Which one larger? That will always write. Clear? Hope you have understood.